Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here is the essay. The year 1628 marks the publication of William Harvey's Exercitatio Anatomica, de motu cordis et sanguinis in animalibus, a treatise that reshaped understanding of the circulatory system. This essay undertakes a detailed examination of Harvey's claims, systematically evaluating the evidence, reasoning, and conclusions presented within each major section of his seminal work. The analysis delves into the specifics of Harvey's arguments, exploring his methodology, evidence, and conclusions while situating them within the context of existing knowledge and subsequent scientific development. Section 1 Introduction to the Anatomical Disputation concerning the motion of the heart and blood in animals. Harvey initiates his treatise by directly addressing the foundational questions regarding the movement of blood within living creatures. He acknowledges the long-standing Gaelic perspective, which posited that blood was generated in the liver, distributed to the body for nourishment, and then consumed. Harvey immediately expresses skepticism toward this prevailing theory, pointing to inherent difficulties in explaining the sheer volume of blood required to sustain the body. He sets the stage for his subsequent arguments by highlighting these perceived inconsistencies, positioning his forthcoming observations as a necessary corrective to established dogma. Harvey carefully states his intention to demonstrate a previously unrecognized dynamic within the animal body, a continuous circular flow to blood. Section 2 on the motion of the heart. This section constitutes the cornerstone of Harvey's groundbreaking argument. He meticulously describes the heart's rhythmic contractions, noting the precise sequence of atrial and ventricular systole and diastole. He emphasizes that the heart, upon contraction, forcefully ejects blood into the arteries, a marked shift from the Gaelic concept of the heart acting primarily as a suction device. Harvey's detailed anatomical observations, coupled with his quantitative estimations of blood volume, begin to challenge the conventional wisdom. Furthermore, he explicitly details the role of the valves within the heart, demonstrating their unidirectional function in preventing backflow and ensuring a directed flow of blood. These valves, he notes, allow flow towards the arterial system and prohibit flow back into the venous system after the heart has completed each cycle. Harvey's descriptions are delivered with a confidence befitting one who has personally conducted dissections and experimental investigations. Section 3 on the motion of the blood into the arteries. Here, Harvey elaborates on the trajectory of blood as it leaves the heart and enters the arterial system. He skillfully employs ligatures and vivisections to demonstrate the unidirectional flow of blood within the arteries. By carefully occluding arteries at various points, Harvey observes the distension of the vessel proximal to the ligature and its collapse distal to it, providing visual confirmation of the heart's propulsive force. He describes the forceful pulse that can be felt when one pulsates an artery, and correlates the pulse with the contraction of the heart that occurs during systole. Harvey also addresses the question of how blood manages to navigate the minute vessels connecting arteries and veins, vessels he could not have visualized directly with the technology of his era. He postulates the existence of invisible passageways, what later became known as capillaries. He reasons that a connection must exist, based on the observable flow of blood from arteries into veins through the Section 4 on the quantity of blood passing through the heart and its circulation. This section presents perhaps Harvey's most mathematically compelling argument. He calculates the approximate volume of blood ejected by the heart with each contraction, estimating this amount to be around 2 ounces. He then multiplies this volume by the number of heartbeats per half hour. The resulting figure yields an astonishing quantity of blood, far exceeding the total volume of blood present in the animal's body if, as the Gaelists maintained, it was absorbed by the tissues. This calculation provided the most powerful evidence against the traditional Gaelic model. Harvey logically deduces that the blood cannot simply be consumed and replenished, but must instead be continuously recirculated. This section provides perhaps the most persuasive numerical support to Harvey's theory of circulation and presents a logical contradiction to previously held beliefs. Section 5 on the circulation of the blood. Having established the heart's role as a pump and the vast quantity of blood it propels, Harvey now explicitly outlines his theory of circulation. He proposes that blood flows from the heart through the arteries, subsequently passes through unseen connections into the veins, and returns to the heart, completing a full circuit. He draws parallels between the veins and arteries, noting similarities in their structure and function, and further solidifies his conclusion through analogy. He carefully describes how the venous system returns blood to the right atrium of the heart. From this chamber, the blood then passes into the right ventricle. From the right ventricle, blood then passes into the pulmonary artery on its way to the lungs. After passing through the lungs, the blood returns through the pulmonary vein to the left atrium of the heart. From this chamber, the blood passes to the left ventricle, where it begins the cycle anew. He acknowledges the lack of direct observation of the arteriovenous connections, admitting that the small size of these vessels made them invisible to the naked eye or the instruments available to him. Despite this limitation, he argues persuasively that the sheer volume of blood necessitates a closed circulatory system. Additionally, the one-way valves prevent the backward blood flow that would be expected in a system that consumed blood rather than recirculated it. The conclusion that blood flows in a circle is clearly stated and supported with logic. Section 6 on the motion of the blood in the lungs. Harvey addresses the role of the lungs within his circulatory model. He acknowledges that blood must flow through the lungs to acquire its vital spirit, as was believed at the time, but he insists that this process occurs within the pulmonary circulation, part of the larger systemic circulation. He describes how the blood moves from the right ventricle of the heart through the pulmonary artery. The blood then passes through the lungs where it presumably picks up the vital spirit. Finally, the blood returns to the left atrium of the heart through the pulmonary vein. From there, the blood enters the left ventricle and is pumped out to the body through the aorta. He carefully delineates the pulmonary circuit, explaining its connection to the overall flow of blood. This connection represents the integration of pulmonary function into Harvey's view of the overall circuit by which blood moves. Section 7 on the communications between the arteries and veins. In this section, Harvey grapples with a critical question of how blood transitions from the arterial to the venous systems. He acknowledges that these connections are invisible to the naked eye but argues for their logical necessity. He suggests that blood seeps through pores in the tissues, connecting the arteries to the veins. He offers the analogy of water seeping through the earth to connect two bodies of water. While lacking direct empirical evidence, Harvey's insistence on these connections provides the theoretical groundwork for the eventual discovery of capillaries. Harvey notes the impossibility of blood disappearing into the tissues after passing through the arteries, given the substantial amount of blood that the heart pumps out. His postulation of pores or connections between the systems represents the only logical conclusion, and he holds to this conclusion strongly. Section 8 on the use and function of the circulation of the blood. Here, Harvey speculates on the purpose of the circulatory system beyond simply transporting blood. He suggests that the circulation serves to distribute heat and nourishment throughout the body and to remove waste products. He envisions the blood as a vital fluid that sustains all parts of the organism. Harvey also discusses the role of the blood in maintaining the body's overall homeostasis. He suggests that the circulation helps to regulate temperature, pH, and other important variables. These suggestions are very compelling because they are supported with empirical evidence relating to the benefits of blood flow to the extremities and body. They are some of the more direct and easily understood claims within the work. Section 9 on the quantity of blood in relation to the size of the body. Harvey returns to the quantitative dimension of his argument, emphasizing the sheer quantity of blood circulating through the body. He reinforces his earlier calculations, demonstrating that the volume of blood pumped by the heart far exceeds the amount that could be consumed and replenished by the body. He calculates that this amount is about 2 orders of magnitude higher than can be explained by previous theories of blood disappearance in the tissues. This section serves as a powerful restatement of the mathematical impossibility of the Gale-Lick model. Harvey argues that his estimates are accurate, and that the previous theories are thus rendered untenable. Section 10 on the experiments confirming the circulation of the blood. Harvey presents a series of experiments using ligatures and vivisections to further demonstrate the unidirectional flow of blood and the role of the valves in preventing backflow. He describes how the application of a ligature to a limb causes the veins distal to the ligature to swell, whereas the arteries proximal to the ligature remain collapsed. This provides further evidence against the Gale-Lick model. He also notes that the veins swell while the arteries collapse when pressure is applied to a limb. This observation further supports the movement of blood away from the heart via the arteries as the returning of blood to the heart via the veins. Section 11 Response to objections and counter-arguments. Recognizing the radical nature of his claims, Harvey anticipates and addresses potential objections to his theory. He acknowledges that some critics may find his calculations implausible or his interpretations of experimental evidence questionable. He carefully presents his response to potential detractors. He responds effectively to challenges to his conclusions, providing further evidence and clarifications to support his findings. Harvey points out that the veins swell under specific conditions and the vessels are shown to swell visibly. Section 12 on the agreement of the circulation with the anatomical structure. Harvey synthesizes his physiological observations with anatomical evidence, demonstrating how the structure of the heart, arteries, and veins aligns with his theory of circulation. He emphasizes the importance of the valves in ensuring unidirectional flow and the strategic positioning of the vessels in relation to the heart. He mentions the relationship between the arteries and veins. The arteries have thickened walls which are very resistant to pressure, while the veins tend to have thinner walls and collapse more easily. He notes that the heart is a very strong structure which is capable of withstanding a great deal of pressure. All of these points are meant to reinforce Harvey's view on how structure relates to function. Section 13 on the application of the circulation to the explanation of diseases. Harvey attempts to apply his theory of circulation to explain various disease processes. He suggests that disruptions in blood flow can lead to tissue damage and organ dysfunction. Although his understanding of disease mechanisms remains limited, this section represents an early attempt to integrate physiological principles with clinical medicine. Harvey's ideas about disease were based on observable anatomical differences associated with the disease state. He believed that a lack of oxygen could be related to a disease process, thus a logical explanation for his Section 14 on the application of the circulation to the explanation of physiological phenomena. Harvey extends his theory to explain various physiological phenomena, such as the distribution of heat and nutrients, the removal of waste products, and the regulation of body temperature. He envisions the circulation as a central organizing principle that governs many aspects of bodily function. The blood, in Harvey's view, also plays an important role in sustaining the tissues of the body with nutrients and oxygen. Without the blood, the tissues would die. This section represents an early attempt to develop a comprehensive physiological framework. Harvey builds a framework of function that describes how the body's many processes are interconnected and work together. Section 15 Conclusion. Harvey concludes his treatise by reaffirming his theory of circulation and emphasizing its significance for understanding animal physiology and medicine. He expresses hope that his work will stimulate further research and advance the field of medicine. Harvey's conclusion is concise and presents the core of his work. Harvey expresses his hope that his findings will lead to future discoveries and improvements in the understanding of physiology and medical interventions. Section 16 The motion of blood before birth. In a supplemental section, Harvey considers the circulation of blood in fetal animals, a topic that presented particular challenges given the unique physiological conditions of the developing organism. He grapples with the presence of the foramen ovale and the ductus arteriosus shunts that allow blood to bypass pulmonary circulation in the womb. Harvey attempts to reconcile these features with his overarching theory of circulation, acknowledging the adaptations necessary to accommodate the fetus dependence on the mother for oxygenation. The anatomical peculiarities associated with fetal development are dealt with reasonably well by Harvey. The unique circulation of the fetus is clearly stated and logically derived. Section 17 Refutation of previous authorities. In this section, Harvey directly confronts the pronouncements of earlier authorities, particularly Galen, whose views on the motion of blood had dominated medical thought for centuries. He systematically dismantles Galen's arguments, highlighting inconsistencies and contradictions in his anatomical observations and physiological interpretations. Harvey presents strong arguments against the Galenic model of blood movement. The arguments are direct and powerful. Section 18 The implications for bloodletting. Following the exposition of the primary argument, Harvey addresses the crucial implications of his circulatory model for the widely practiced therapeutic technique of bloodletting. He points out that, given the circulation of blood, venesection cannot simply deplete the body of excess humus as previously believed. Instead, blood is continuously replenished from the circulating reservoir, rendering the procedure's effects more complex and nuanced than previously understood. Harvey refutes the notion of removing unwanted humus through this procedure. His findings suggest that bloodletting is less effective, and that the benefits are not what was previously thought. Section 19 on respiration. Harvey dedicates a section to further detailing the process of respiration and the role of the lungs in aerating the blood. He expands upon his discussion of the pulmonary circuit, emphasizing the importance of the lungs in infusing the blood with vital spirits. Harvey describes in great detail how the blood uses the lungs to become oxygenated and enriched in a way that sustains the body. The process of aeration enriches blood is a key aspect of the circulatory process. Section 20 Digressions on various topics. Harvey introduces a series of digressions, exploring related topics and offering further insights into the workings of the animal body. These digressions serve to enrich his overall argument and demonstrate the breadth of his knowledge. Harvey expands upon the various topics related to the body's organ systems and their processes. The topics represent an effort to fully explain the intricacies of the animal body. In conclusion, William Harvey's De Motu Cordis represents a paradigm shift in the understanding of animal physiology. His meticulous observations, quantitative calculations, and logical deductions provided compelling evidence for the circulation of blood, challenging a long-held Galenic dogma, while some of his specific explanations, notably regarding the connections between arteries and veins, lacked direct empirical confirmation. His overall theory proved remarkably prescient and laid the foundation for modern cardiovascular physiology. The significance of Harvey's work lies not only in its accurate description of the circulatory system but also in its demonstration of the power of observation, experimentation, and mathematical reasoning in advancing scientific knowledge. His meticulous experimentation, coupled with the elegance of his theoretical framework, forever altered the landscape of anatomical and physiological research. Harvey's contributions remain central to the ongoing endeavor to understand the workings of the human body.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.